In this video, I will show how to simplify exponential expressions that contain rational exponents. So what is a rational exponent? A rational exponent is interpreted in the following way. If you have a raised to the power m over n, this can be interpreted as either nth root of a to the power m, or it can be interpreted as nth root of a raised to the power m. So now, once we understand what a rational exponent is, we next have to understand that simplifying rational exponential expression is exactly the same as before. That is, we just have to make sure that there are no base repeating multiple times, there is no negative exponents, and there is no power to power. So let's get started. We're going to look at the numerator and the denominator separately. In the numerator, there isn't much going on, so to multiply those two expressions, we just have to use the properties of exponents. However, in the denominator, we have a power, we have something raised to a power, and that means that power has to be distributed in each product. So before I do anything in the denominator, I'm going to distribute the power 1/2 to 9, and I'm going to distribute the power 1/2 to x to the power 5/4, and then I'm going to distribute power 2 to 10, and I'm going to distribute power 2 to x to the power 3/8. Now 9 to the power 1/2, according to this interpretation, is same as square root of 9, which is 3, and 10 squared, we know it's just 10 times 10, which is 100. And the power to the power expression can be simplified by using this property. So what I have in the numerator can be rewritten as negative 5 times 6 times x to the power negative 1/3 times x to the power 4/9. And what I have in the denominator can be rewritten as square root of 9, 3, 10 squared is 100, and x to the power 5/4 times 1/2. 5/4 times 1/2 is actually 5/8 times x to the power 3/8 times 2, but 3/8 times 2 is just 3/4. So this expression can be simplified by combining all the powers of x and then working out all the coefficients separately. So we have negative 30 over 300, and in the numerator we have x to the power that's determined by this property. When you have the product of two exponential expressions with the same base, the powers are actually added. So in the numerator we have x to the power negative 1/3 plus 4/9, and in the denominator we have x to the power 5/8 plus 3/4. So negative 1/3 plus 4/9 is actually negative 3 over 9 plus 4 over 9. It's just 1/9, and 5/8 plus 3/4 is just 5 plus 3 times 2 over 8, which is 11 over 8. So in the numerator we have x to the power 1 over 9. In the denominator we have x to the power 11/8. And the coefficients can also be simplified. Negative 30 over 300 is the same as negative 1 over 10, and it can be written like this. Now we can simplify it further by using this property, that x to the power m divided by x to the power n is actually equal to x to the power m minus n, and therefore what we have can be written like this: negative 1/10 times x to the power 1/9 minus 11/8. 1/9 minus 11/8 can be computed. So I'm just going to make some room over here. Uh, 1/9 minus 11/8. The common denominator is 72. So we have 8 minus 99 over 72. 8 minus 99 is negative 91 over 72. So the answer is negative 1 over 10, x to the power negative 91 over 72. However, we're not allowed to have negative powers, so the last thing we have to do is we have to interpret the negative power and rewrite the expression using this rule. X to the negative power is just the reciprocal of x to the corresponding positive power. So the final answer is we're going to have negative 1 over 10 times x to the power 91 over 72. So that's the final answer. We can easily verify that all three conditions are satisfied. There is no x, base x appearing in more than one expression. There is no power to power, and there are no negative powers. So this expression, this exponential expression, is simplified.